Hello everyone. This lesson is going to be on significant digits and rounding, and I'll follow this up with another lesson which will be on unit conversions or dimensional analysis and scientific notation. So what significant digits does have to do with is the accuracy with which we can take a measurement and the number of digits we can actually record. So if you're measuring in milliliters using a graduated cylinder, there's only a certain degree of accuracy that you can have. If you're measuring grams using a balance or measuring distance using a ruler, like I'm going to do in this example, you can only give so many digits because of the limitations of your measurement instrument. So in the case of the ruler here, we're going to take a look at measurements in centimeters, and what we'll see is that you can only be so accurate, and that's only the number of digits that you're allowed to record in terms of the accuracy or the precision with your measurement. So let's go ahead and let me drag the ruler over the rectangle that we have here and take a measurement. So we're going to be using the left-hand side of this ruler, which is the metric system. The right-hand side is the imperial system. These are kind of thick lines in the rectangle, but I'm going to use the outside of it, and I'm going to try and line up as best as I can at the bottom the 0. And then we're going to go up along the left-hand side and measure the height of this rectangle here. So I'm just going to grab a pen here as well so I can write on the screen. So down at the bottom, that's where I have my 0 here, as best as I could line it up. And this is part of the inaccuracy, is how accurately can you actually line it up along this fairly thick line. Different people might see it in different ways. This is our 4 centimeter mark that we have here, and our 5 centimeter mark. So what we then know is that the top of this thick line on the rectangle, it's definitely less than 5, and it's definitely more than 4. So it is 4 decimal something centimeters. So what is that something? Well, now if we measure up from the 4 and count the millimeters, we can probably all agree that we count up to 9, and it's definitely 4.9. So these two numbers we know for sure, but if you look really carefully, you'll be able to see that actually it's a little bit more than 9. It's definitely more than 4.9 and definitely less than 5.0. So this third number, we're not going to be able to be bang on. Different people will see it in different ways, but here I'm going to call it 4.93. Always include the units. Units are centimeters that we're measuring in. So this is recording the number that we do have to the correct number of significant digits, or I'll just simply call them sigdigs. So what did we just determine? Well, the two numbers that I have a check mark above, we know those for sure. There is no question about those. We count those in terms of the number of significant digits in this answer. But also what I get is I get one number where I'm not exactly sure. I'm kind of guessing on it, but we get to count that one as well in terms of the number of significant digits. So what we would then say is this answer has 3 significant digits. So I would be wrong to rate this as 4.9 because I can actually do better. I would also be wrong to rate this as 3.564 because I definitely do not know about these ones here. Absolutely not. So that's why the correct number of significant digits is going to be our 3 significant digits, and it is an indication of the degree of accuracy that we can ascertain using this particular measurement instrument. So if you are given a number, you will need to determine, for starters, how many significant digits there are in that number, because when you do a calculation, it's your original number of significant digits that you have that typically will determine how many digits you can have in your final answer as well, following a calculation. So here I just have a number of digits that we'll take a look at for examples, and this is what we say: numbers 1 through 9, we always count them as being significant digits. Leading zeros. What are leading zeros? If I give you a number here, 0.04502600, this is a number that's less than 1, but I have a whole bunch of digits here. So these ones that I have in front, they are called leading zeros. And no, I don't count them in terms of significant digits. Any of the numbers that are other than 0, I count them. So I'm going to count the 4 and the 5, the 2 and the 6. Any 0 sandwiched in between, I count those as well. So all of these ones here, yes, they are going to be significant. These ones at the end, what we're kind of saying is that we actually measured to this degree of accuracy. We were absolutely positive about this one. This last one, we're not entirely sure, but we get to count it as a significant digit. So these ones at the end, they are what we call trailing zeros. And yes, we do get to count them at least most of the time, as we will see. So using that, let's take a look at the numbers that we have here. So the first one, 107.63. We have no leading zeros. We have no trailing zeros. We have a 0 that's sandwiched in the middle. So we do get to count it. So we're just counting all of these numbers. So starting with the 1, we have 1, 2, 3, 4, 5 significant digits. You do not count the decimal. It is not a digit. If we take a look at the next one, these 3 here are all leading zeros. So no, we don't count them. This one at the end though, trailing, we do count that one. That is significant. So all of these numbers here, 4, 5, 9, 0, are all significant. We have 4 significant digits. It's this one here that becomes kind of ambiguous. It depends upon what we're talking about in terms of the measurements. So if you do actually have a meter stick, and if you do actually measure, and if it is 200 meters, then you would record 200. And that would be, well, possibly 3 significant digits because these are trailing zeros. However, if you're at a track meet and they say that it's a 200-meter race and you're not actually going out there and taking a measurement to see how accurate it is, you're just calling it a 200-meter race. So it's in that situation here that it does become kind of ambiguous that probably you wouldn't count these because you didn't actually measure and you're not really sure. But if you did truly take the measurement and it is 200, then that would be 3 significant digits, counting the trailing zeros. And for the purposes of this course, for the most part, we will count those trailing zeros. So that would be a similar case with this one here. Whole bunch to count. This one at the end will count. A couple in the middle will count. So this is 1, 2, 3, 4, 5, 6, 7 significant digits. We'll talk about scientific notation in another lesson, but whenever you see this, 10 to the 4, 10 to the negative 6, this is scientific notation. If you have this number 4 and it's a positive number, that means that this is actually a really big number. If you have a negative exponent, that's a really small number. So what this number here really means is 27900. 27,900. Why are we writing it in scientific notation? Well, because it's a big number, and it's sometimes easier to write it in scientific notation. Or we may have done a calculation, and we may have determined through the calculation that you can only have 3 significant digits. So if this number has to be written with only 3 significant digits, you can't just say, well, I'll just get rid of those last 2 zeros and call it 279, because clearly 279 and 27,900 are not the same. So how do we write this number here with 3 significant digits? Write it in scientific notation. So right now the decimal is here. We're just going to move it over 1, 2, 3, 4 places. And that's actually where this 4 does come from. So what numbers do we count when it's written in scientific notation? You never count anything here. Do not count those. We only count these numbers. So this one would then have 3 significant digits. This one here, using the same rules as above, we count the 1, we count the 3, we count the trailing zeros. So that would have 4 significant digits. So what if you need to do some rounding to the correct number of significant digits, which you will have to do. So the rounding protocol that we use is to ensure that the number of significant digits you have in your answer is to the correct degree of accuracy after your calculation. So if the number following, and this is kind of wordy, if the number following the desired number of significant digits is less than 5, then the last digit remains the same. So let's say we have this number here, 2.4396. If you're told to round to 2 significant digits, that would be these ones. But what you need to do is take a look at the next number. If it is less than 5, as it is here, you don't change that number 4. So your answer then becomes simply 2.4, correctly rounded to the number of significant digits that you were told or that you determined. If the number following the desired number of significant digits is greater than 5, then we're going to bump that last number up. So if I just change this a little bit to 2.4696, and if I'm still rounding to 2 significant digits, take a look at that next digit after what you're rounding to. If it is 5 or greater, what we're actually going to do is bump this one up. So that then becomes 2.5 rounded to 2 digits, 2 significant digits, or 1 decimal place. So for this one here, this example, I'm just saying to round to 2 decimal places. I could have asked for the number of significant digits as well, but here I'm just going to go with decimal places. So 2 decimal places, that would be the 100th position. So in our first number that we have here, it would be to this one. I can only have 4 digits to 2 decimal places to the 100th position. So what I'm going to do is take a look at the next one though, and it's a 4. And that means that the 47.23, I'm not going to bump that 3 up. I'm going to keep it as 3. Okay, that is 47.23. For the next one, now rounding to 2 decimal places, the next one after the second 3 is 5 or greater. So we're actually going to bump the previous number up. So this becomes 0.34, correctly rounded to 2 decimal places. And the last one a little bit trickier. So rounding to 2 decimal places, we want to only have to the 100th position. The next one is 5 or greater, so we need to bump this one up. But bumping up a 9, it becomes 10. So your answer actually becomes 0.10, correctly rounded to 2 decimal places. So let's go back to our rectangle, and now let's do some calculations and make sure that we can determine the correct number of significant digits in the final answer following a calculation. So there are different rules for adding and subtracting numbers that I'll talk about first, as there are for multiplying and dividing. So from our original rectangle, I'm just going to say that the original length or height was 4.95, and I should always have the units in here. That was in centimeters, and the width 2.40 centimeters. So notice that each of these, for starters, they have 3 significant digits, and they both are to the same degree of accuracy, which is 2 decimal places. And I'll write that down as well, because that's what's going to be kind of important for adding and subtracting, is the degree of precision in the answer. Both of these, their degree of precision is to 2 decimal places, or the 100th position. So now if I want to calculate the perimeter of that original rectangle, so I'm going to add together the 2 lengths or heights and the 2 widths. So all these numbers that I have here, again, every single one of these should have centimeters after them, as should my final answer, which is 14.7 centimeters. However, even though this number here is correct in terms of what you will get when you plug these numbers into your calculator, once again, every single one of these is to the same degree of accuracy, and it's 2 decimal places. So this is what the rule says for adding and subtracting. When adding and subtracting numbers, you are going to round your answer so the last digit of your answer has the same place value as the last digit in the least precise number used in the calculation. These are the numbers that we used in the calculation. They were both to the same degree of precision, but it was to 2 decimal places. So this is kind of weird. So here, this is the number that our calculator gives us, but we can actually record a number that's more precise. We get to record this as 17.70 centimeters. So that is the rule when you are adding and subtracting. What we do go by is the same place value as the least precise number that was used in the original calculation. Okay, so let's do it for a few other ones here. So in this first example that we have, most of these we can just kind of do in our head. So again, this one here is kind of iffy, right? So do we count it as 3 or do we count it as 1 significant digit? It's not going to matter at any rate for the adding and subtracting. When we add these together, we do simply get 219.74. Which one is the least precise? This one is the least precise. What does that mean? Your final answer has to have 3 digits as well, or has to be to the nearest whole number would be more correct. So we need to round this to the nearest whole number. So this is what we want, but we need to take a look at the next digit. It's 5 or greater. So rounding actually says we're going to bump this up. So the correct answer then would be 220. Again, we rounded it to the nearest whole number because that is the least precise number in our original calculation. So what I'll do is I'll circle the ones that are the least precise. This one goes to 3 decimal places, the 1,000th position. This one only to 2 decimal places, the 100th position. So this one is the least precise. This one to the 100th, this one to the whole, this one is the least precise. This one goes to 4, this one to 3, this one is the least precise. Okay, so we need to keep that in mind. We're going by the precision for the least precise number when we're recording our final answer. So this one here, when we add them together, we get 0.43, 43, 0.466. All right, just adding those two numbers together. So now what I need to do is I need to round, but my rounded answer can only be to the 100th position. So again, what I'm going to do is I want these ones here. I need to bump up the previous one because this one here is 5 or greater, and it becomes 0.47. Rounded to the number of, or the decimal place that we do find in the least precise original number. Next one here. We have 27.39 minus 12, so that's going to be 15.39. But we need to round it to the nearest whole number. So that would be simply 15 in this case. And then this one that we do have here, plug those numbers in, and we end up with 0.837, and that one is to 3 decimal places, as is our answer that we have, our original number that we have. So this one is fine the way that it is. So it is important for you to keep in mind that these are the rules for adding and subtracting numbers and rounding it to the correct number of significant digits. Having said all of that, most of the time in this course, we're actually not doing addition and subtraction. We're doing multiplication and division. And unfortunately, it's a different rule when you're multiplying and dividing numbers. So now, from our original rectangle, we're going to calculate the area, the length times the width. So again, I should, of course, have centimeters in here for each one of those. And when we do the calculation, it ends up being centimeters squared. At any rate, the numbers that we do have here. So if we do take a look once again at our 2 original numbers, so here what I'm going to talk about is not the place value, not where the decimal is, but what I'm going to talk about is the actual number of significant digits. So in both of these, we already saw before, it's 3 significant digits. So the rule for multiplying and dividing is that after your calculation, you need to round to the same number of digits as the number of significant digits in your least precise number used in the calculation. So what does that mean? Well, we have this number, 11.88. Both of our original numbers have the same degree of accuracy. That certainly will not always be the case. Sometimes one will have 2 significant digits, the other one might have 5. In this case, they both have 3. So what that does mean is that your final answer has to have 3 significant digits as well. But wait a minute, our final answer has 4. You can't give a number this precise based on our original number. So what that means is we need to convert this into an answer that has only 3 significant digits. So we're going to drop this final 8, but before, because it's 5 or greater, we're going to bump up the previous 8. So this then becomes 11.9 centimeters squared, rounded to the correct number of significant digits, which is the 3 significant digits. Let's do a few quick calculations here. I'll need to plug some of these numbers into my calculator as well. So if we're taking 4 times 0.35, multiplication, what we end up with is 1.4. Okay, so let's take a look. With the 4, we have only 1 significant digit. With the 0.35, trailing zeros are significant, leading zeros are not. So here we have 2 significant digits. The one that is the least precise then is the 4, which means our final answer can only have 1 significant digit. So again, this might seem kind of strange. Our number is 1.4, but we actually can only give 1 significant digit. So we need to, well, either round this one up or keep it the same, but because it is a 4, it's less than 5, that means we keep it the same, and it is simply 1 that we do have for the correct answer to the correct number of significant digits. Next one is division. So we have our 0.47 divided by 2.345. And I'm going to write quite a few digits from my calculator here. So we get 0.2004. I'll write a few more in here as well. 264. And there are more, but we don't need any more digits than that. So let's take a look at our original numbers that we do have. 0.47 is 2 significant digits. This one here is 4 significant digits. So our final answer needs to have the number of significant digits as your least precise. So we can only have 2 significant digits. Remember, the 0 in front is not leading. We put in the 2, and then we get to put in 1 number after that. So the 0 is followed by another 0. So we're going to keep that the same, 0.20 to the correct number of significant digits. Next one that we have here, 438 has 3 significant digits. This one here has 5 significant digits. So our final answer, when we take 438 and divide it by our 127.45, also has to have 3 significant digits. So a bunch of numbers from the calculator, 3.4366. And again, there are more, but I'll keep it with that. We only need 3. These are the 3, but the number after the 3 in the 100th position is a 6, so we're actually going to bump this one up. And our final answer, correctly rounded to 3 significant digits, is then 3.43. And the final one that we have here, so 0.900 divided by our 3.89. So here we end up with 0.23136. That should be good enough. Trailing zeros are significant. This one has 3. Well, so does this one. Also have 3. So our final answer is 3. Okay, remember this one here, we don't count. Need to be careful with that. So we have 0.23136. 2, 3, and we get one more. The 1 is followed by 3, so we don't bump it up, and we end up with 0.231. And we'll leave this one for another lesson on scientific notation.